Hi guys, Anton here. Almost a month ago, I was in the Netherlands, invited by the BNA to talk about the Passive House concept and principles. So I thought to share this journey with you. And it's my very first attempt vlogging, so please don't be too critical because I can already warn you that the audio of the presentation is, well, a bit crap. But anyway, must say that as someone who's been living in the Netherlands for 8 years, it was super exciting to go back, and especially for this occasion. But before I continue, let me first tell you what is BNA. It stands for Branchevereniging Nederlandse Architectenbureaus, or in English, the Trade Association of Dutch Architectural Firms. And here we met more specifically the local chapter, which is the Rotterdam Circle. And they're helping their members to create more sustainable buildings, more sustainable living environments, but also businesses. So here is how it all started.
Anton, where are we going now?
We're going now to the Het Nieuwe Institute.
Yeah.
And tonight there is a whole evening about the Passive House standard. So sort of like the Dutch Architectural Association in the Netherlands organizes an evening about the Passive House standard, and I'm going to present there. And it's funny because the institute is there, and here in this building a few years ago I was watching a lecture given by Daniel Libeskin, who is like one of my favorite architects. So it's a huge pleasure for me that I'm going to give this lecture today.
Yeah, are you excited?
Yeah, definitely.
Do you know who is going to be there?
A few of our course participants, a few of our colleagues, the people who we work with on Passive House project here in the Netherlands, and I'm looking forward to the architects who I'm going to meet who are also interested in making more energy efficient buildings.
What are you going to talk about? Please tell me that you're not improvising.
No, it's all prepared.
Are we there yet?
Not yet, but you can enjoy the beautiful landscape of
Oh yeah,
architectural masterpieces here. So
look
here
at
we have
this.
a building by NVIDV, Boymans Museum, then Het Nieuwe Institute, in which is going to be the presentation. Then there we have one of the skyscrapers in front of us. I think it's called the Kooltoren. And here we have the other skyscraper, which is designed by Khan architects.
Can those be passive?
These are not, but they can be.
Looking forward to it.
Me too.
Now let's see the part of my presentation where I explain the basics of the Passive House standard. Before we focus on the Passive House principles, let's look at the big picture and see why do we even need those types of buildings. So if we look at the energy consumption in the different sectors, we can see that the buildings account for 37% of the total energy consumption in the world. And that's the biggest energy consuming sector. So, and then if we zoom in and check, okay, but where is this energy going for? Well, 65% of the energy goes for space heating and cooling, and then 14% goes for domestic hot water. And that's from a study by Eurostat in 2021. So that's quite recent data. So all we know, both of these, space heating and domestic hot water, they account for 79% of the total energy consumption in our buildings. And this means that there is a huge potential for optimization of the energy consumption in the buildings. And that's exactly what the Passive House standard focuses on. So we can achieve a 90% energy reduction in the energy demand by following a few simple principles. And here we have a very nice overview of how energy efficiency evolved in buildings. So starting with until the 19th century, people were gathering around the fireplaces, and that's something we can read about in the books as well. Well, they were doing so because that was the warmest place in the house, and then the other rooms were just cold. Then in the 20th century, we invented technology, mechanical services, and we just started putting in those services in our buildings without thinking too much about the design, which is something I think we're all interested in here. And then in the 21st century, we looked at the big picture and started focusing more on the design. So making the building more energy efficient, and then just adding the mechanical services that we need in order to really create a comfortable building. And all of these can be achieved by following a few design strategies, and we call them the 5 Passive House design principles. So the main goal of those principles is to make a building or to optimize the building so that it loses less energy through the thermal envelope. And the first principle is thermal insulation. So that's like wrapping the whole building around with a warm blanket in order to keep the heat inside of the building. And the benefits are reducing the heat losses and creating comfortable interior surface temperature. So we don't have any more cold surfaces inside of the building. And for this, we create an energy model, which is something Jan is going to talk a bit more in detail, of the whole building, and we use third-party tested data because our goal is to create a building which is, or to create a model which is very accurate, so that after that, when we build the building actually performs as we've modeled it to do so. Then the second principle is air tightness. So imagine you're outside in winter, you have a sweater on, but when you're with the sweater on and there is a wind outside, you're still cold because the wind goes through the sweater. So even though we insulate our buildings, this does not mean they're airtight, and that's why we should focus on air tightness. So in the Pascal's field, we have this saying, we should follow the pencil rule, or in other words, we should, along our thermal envelope of the building, we should be able to draw a single continuous line all around. And this firstly reduces the heat losses through infiltration, so again, minimizing the energy consumption of the building. Reduces the drafts, because when we make a more airtight building, the cold air is not going to be coming inside, and it will create a more comfortable building. And it also reduces the possibility of moisture damage to the structure. So we protect the structure so that it's long-lasting and needs less maintenance. And it also protects the insulation and ensures its effectiveness. So during the design stage, we make sure that the building is airtight, that all the connections are airtight, that all the buildups are airtight. And then in practice, after the building is built, we make the so-called blower door test in order to actually test the airtightness of the building, and if there are some leakages somewhere, spot them and fix them. And now we come to the third principle. So the thermal envelope is not only the opaque, but it's also the transparent envelope, or in other words, the window. So we use high-performance windows because that's the only place through which we gain energy. So our goal with the windows is to choose windows which bring in as much of the solar heat inside, but minimizing the heat losses. And one of the other main benefits of using high-performance windows is the comfortable surface temperatures. So our goal is that the temperature of the window is more or less the same as the temperature of the wall. Because otherwise, when we have, for example, double glazing in the Netherlands, if we stay somewhere next to the window or close to a double glazed window and outside it's cold, we can have a feeling of cold drafts and even a feeling of cold feet. And it's experienced as very uncomfortable. And that's something that we define even during the design stage. So when we make this energy model, we can check whether all the surfaces inside are going to be warm enough, and on top of that, whether we're going to avoid mold and condensation. And for the windows, we include all the different parts, so we don't look at it as a window, but we look at it, the frames, the glazing, the type of gas that's inside of the glazing as well. So we focus on each and every small component. Then the next principle is thermal breach-free design. So every insulation system, every thermal envelope has its weak spots. So there are going to be places which are less insulated, or there are going to be places in which the insulation is penetrated, and these we call the thermal bridges, and we fix them for two reasons. The first reason is, again, to reduce the heat losses and make a more energy efficient building. But then the second reason is in order to avoid mold and condensation, and to have, again, comfortable surface temperatures. And for this, we make the so-called thermal breach calculations, and this we make during the design stage. And again, the result of those calculations is that we can see whether what the surface temperature is and whether we're going to have potentially mold or condensation. And that's why we say that we can quantify comfort and health, because by making those calculations, we actually check whether all of this is met. And last but not least, after we make a very energy efficient building, a very airtight building, the air is going to stay inside, because with normal buildings, the air just goes through the windows, it goes through the walls, the roof. But here we focus on air tightness, so there's no way for the air to go in and out. That's why we use a ventilation system with heat recovery. So the benefit of this ventilation system is that the air that goes out of the building gives off the heat to the air that's coming into the building. And if we compare it to extract ventilation systems, or type C as called in the Netherlands, there the fresh air is coming in from the windows. We constantly have to heat it up, and then we extract it and bring it to the outside. And that's exactly what this ventilation system focuses on, basically, that we don't lose the heat and we avoid constantly having to reheat the incoming air. So by following these 5 Pascal's principles, we can scientifically measure and calculate the energy efficiency and achieve 90% reduction in the energy demand for heating and cooling. However, we can also quantify comfort and health. And for all passive house projects, we make sure during the design stage that there will be no mold, which is what we see here, the connection between the window and the ceiling, that there is not going to be any cold surfaces, and that's an image of a single glazing here in the Netherlands of an existing building. You can just see how much condensation there is on the glass. And yeah, the cat is licking this condensation, and this cat also has problems with the bladder, unfortunately, and it's exactly because of this. Because there, where we have the condensation, we also have mold. And yeah, then people who are living in these kind of buildings, they're breathing in this air, which is very unhealthy. Then there are also no drafts. Here we see a thermographic image of a front door that's in a standard building, so not a passive house. We can see how the cold air is coming in through the door. And that's something you cannot observe in a passive house project. And of course, we make sure that we have fresh filter there. So we chose the right ventilation system, we chose the right filters, and instruct like what's needed to, or we design the system so it works properly to make sure that we have fresh filter there, and also that the ventilation system maintains good humidity levels inside. And all of those principles, they're also applicable to existing buildings as well. To existing buildings, they're applicable to houses, to skyscrapers. Here we see Hotel Marcel, which is a brutalist monumental building. It's been renovated to the passive house standard. Here we see Ken Sobel Tower in Canada, again, a renovation of an apartment building. And if we compare a standard building to a passive house building, well, the standard building has high heating and cooling demands. That's why in a standard building we know we need all these AC units, which here in the Netherlands is not so common, but if you go a bit more in Eastern Europe or Southern Europe, you will see them everywhere on the facades. And in the passive house building, well, we have a 90% lower heating and cooling demand. Then we have discomfort and unhealthy environment, exactly what we saw with the condensation and the mold. While in the passive house, all of this is avoided, and we have a comfortable and healthy environment. These buildings, the standard buildings, existing buildings, they have a negative impact exactly because of this high energy consumption, while passive houses, they have a positive impact because the energy consumption is reduced, and the benefit is also for the users that we have very low operational costs. So the energy bills are drastically reduced. But people say, well, passive house is too expensive. Well, what I say is it really too expensive? That's the building, it's a certified passive house in Sofia, Bulgaria. That's the building in which my parents are living. And they've been living there for 6-7 years already. And now I'm going to show you the calculations that we made. So that's the economic profitability for 30 years. What we've compared here is firstly we have the passive house building. Then we have a building which is built to the local regulations, so local code. And then we have the step-by-step to the passive house classic, or in other words, if we start with a building which is built to the code, then we add the insulation, then we add the thermal bridges or minimize the thermal bridges, then we make it also airtight, add the ventilation system, and then the last step is to make it a passive house. Now we're going to focus on those two because we cannot make a comfortable and healthy building without combining all the principles. And that's something to remember from this presentation, because you cannot create a comfortable building without having a ventilation system with heat recovery, because then you're not going to have fresh air, then you're going to have too much of a humidity inside. So that's why it's very important to always follow those principles and to think of the passive house as a one living unit, right? And I like to compare it with the human body. So in the body we have the skin. In the passive house we have the air tightness. In the body we have the fat, which protects us from the cold. In the passive house we have the insulation. In our body we have the lungs in order to breathe. In the passive house we have the ventilation system. So coming back to the slide now, let's focus on the first two cases. Here we see that for 30 years the passive house costs much less compared to the standard building, and that's all the costs, so operational costs plus investment costs in total, and that's in euros per square meter. But you would say, okay, 30 years is too much it's too long period. Well, the return on the investment for this house was 7 years. Here you see that at year 7, the passive house costs just as much as the standard building. Or in other words, after the 7th year, the people who are living there, or my parents basically, they're gonna only save energy due to the very low energy costs and energy consumption of the building. And therefore, the passive house shifts the decision-making factors. So if these are the decision-making factors currently, where we have profitability as the biggest factor, then comfort, and lastly sustainability. Well, what the Passive House standard does is it combines them all at the same scale. And that's what we need in order to create a more sustainable future. So Passive House is also the first step to making a net zero building. So by focusing on the energy efficiency first, we can easily cover the remaining energy demand with renewables on site. Here we have a low energy building, the energy consumption of a low energy building for heating. Here we have it for a Passive House building where it's around 80% reduction. And by reducing the energy consumed for heating and cooling, we can easily cover it with renewable energy on site, like by putting some PV panels on the roof, for example. And that's why I believe Passive House is the future. And we can also see it over the world. For example, in the UK, in 2019, the social housing project, it won the Sterling Prize. And that's one of the most prestigious architectural awards in the UK. We also have currently the first proper skyscraper is built according to the Passive House standard in Canada. And even governments are mandating, in some place over the world, they mandate that the new buildings have to be built to the Passive House standard. So if I have to sum it up, the Passive House standard combines economic profitability, comfort, and environmental friendliness. And that's why I say that this is the first and only building standard that combines on one side the personal interests and desires of the individual with the public need for environmental protection. Because the residents, they're living in a very comfortable building without any mold, with fresh air, with very low energy bills, while it's very beneficial for the environment as well because this building saves a lot of energy. So I hope that you found this presentation interesting. I hope that you found it useful as well, and that you're also now much more motivated to make buildings that are not only energy efficient, but also comfortable and healthy. Presentations also did Jan and Ilko. And their presentations were in Dutch, so I'm not going to share them here, but they were super interesting, and I'm going to tell you briefly what the presentations were about. So Jan is a Passive House consultant, and we certify some of the projects he's working on in the Netherlands. And he compared the Passive House standard to the local NZEB standard. And NZEB stands for Nearly Zero Energy Buildings, or in the Netherlands they call it BANK. And there was one slide that I really loved about his presentation, so I'm going to share it with you here. Namely, a comparison that shows how the energy modeling or the results from the energy modeling would look like if there were renders. Where on the left we see the results from the Passive House calculation and on the right from the bank calculation. And then we also have Ilko, our ex-student from the Certified Passive House Designer course, who talked about his bio-based Passive House project, which he just moved into, and of course the project that he is currently working on. And we made a whole YouTube video about his project, and you can watch it right here. In the video we make a tour around the building, and it's very interesting, so definitely make sure to check it out. And after the presentations we had a panel discussion and talked about the history of the Passive House standard, how Passive House can be combined with bio-based materials, the applicability of the standard for larger buildings, and of course we busted some of the myths around the standard. And by the way, I've made a whole YouTube video about the 6 myths of the Passive House standard, which you can watch right here. I hope you enjoyed this video, and I'm curious to know if you would like to see more of my day-to-day life projects and these type of videos. So let me know in the comments. Thanks for watching.